What's up, Algebra 2? Okay, last video we talked about multiplying and dividing rational expressions. Oh look, it didn't even include expressions on my title. That's supposed to say rational expressions, by the way. That's better. So this video we're going to talk about how to add and subtract rational expressions. So, biggest thing is that it is just like adding and subtracting regular fractions. And when you add and subtract regular fractions, you have to have a common denominator, right? Okay, so same deal here. You got to figure out a common denominator. So most of our first examples are just going to be with common denominators, and then after that I'll show you how to get a common denominator with rational expressions. But first, if you already have a common denominator, you're happy because you don't have to do as much work. But anyways, after you figure out you have a common denominator, you just keep your denominator and then add or subtract the numerators. Then if you can simplify, definitely simplify. Okay, so first we're just going to do it with do an example with just regular fractions. So you do -2/7 minus 5/7. Hey, look, there's already a common denominator, so keep it, don't change it, and just add or subtract the numerator. And since we have a subtraction, we want to subtract. Okay, so then this looks like -2 minus 5 all over 7, which ends up being -7 over -7 over 7, which simplifies to -1. And then that is my answer. Yay! Alright, example 2 is actual rational expressions. So, you have to look at the denominator first. And my first denominator is x minus 1 times x plus 2. My other denominator is x minus 1 times x plus 2. So, same denominator. Yay! So that means we don't have to do a whole lot of work. All we have to do is just rewrite the fraction, subtract the numerators, and then leave the denominator the same. Here's where the simplifying comes into play. That x minus 1 is like x minus 1 times 1. And so, since I have an x minus 1 in the numerator and denominator, I can cancel them out. So I've got x minus 1, and I'm left with a 1 over x plus 2. But remember, you cannot have a 0 in the denominator. Really bad things happen. Don't do it. So anyways, you gotta tell me what the denominator cannot equal. And at any point in the problem, the denominator cannot equal 0. So from the top, right, here, x cannot equal, well, x minus 1 times x plus 2 cannot equal 0, right? And so that, if we solve that equation, we have to set each one individually equal to 0, and we get x cannot equal 1, or x cannot equal -2 as well, because both of those would make the denominator 0. Bad things. Okay, now for the kind of tricky part. What if you don't have a common denominator? Because then it gets a little trickier. You just have to find the common denominator, which sometimes can get just a little hairy. It's not that bad though, I promise. Okay, really, step 1 is to simplify as much as you can before you do anything. So if you can cancel stuff out, do it. It'll just save you some time later. That includes canceling out any common factors that the numerator and denominator have. Next, find the least common denominator of all of the fractions that you have. Then you're going to multiply by the appropriate value, which I'll show you what that means in a second, to make both of them have the same denominator. Then add or subtract like normal. You add or subtract the numerators and then keep the denominator, and then simplify whatever you can. It's really not that bad. It sounds kind of bad, there's a lot of steps, but it's just like doing it with fractions, so it's not that bad. Okay, so let's look at example 1, which is 3 over 24 plus 5 over 16. So just as a refresher how to do this with numbers, and then we'll look at how to do it with rational expressions. Okay, so first and foremost, before you can do anything, you have to find a common denominator. So for me, this is just a personal thing. I like to break up 24 and 16 into things that I know are going to help me. So I'm going to write 24 as 8 times 3 and 16 as 8 times 2. Cool thing is, we've got in the first fraction I have 3 over 8 times 3, and so those 3's can cancel, and I'm left with 1 over 8, so that's kind of nifty. Okay, so now I have 1 over 8 plus 5 over 16, or 8 times 2, and so all you got to figure out is what do I need to multiply each fraction by in order to get a common denominator. And if you have it broken down into some sort of factorization that makes sense, 8 and 8 times 2,
rational functions rock!
Woo! Sorry, I totally got distracted. Where was I? Okay, so I think we need to find a common denominator. There's 8 and 8 times 2, and so all we really need to do is multiply the first one by 2. But here's the problem. If I multiply the denominator by 2, I've officially changed the fraction. Now it's 1 over 16, and we can't change the value of the fraction, so I have to multiply by 2 over 2, because then I'm only multiplying by 1, which doesn't change the problem at all. It just makes it look different. And what's algebra about? Haha, it's all about making things that you don't know how to deal with look like things that you do know how to deal with. So that becomes 2 over 16 plus 5 over 16, which is 7 over 16, and you can't simplify it anymore. That's the answer. Woohoo! All right, now how to do it with rational expressions. So let's look at example 2. I've got 2 over x plus 1 times x minus 2 minus x over x plus 1. And so, got to figure out what your common denominator is. Now, the first one is x plus 1 times x minus 2, and the other one is x plus 1. And so our least common denominator, you can't get rid of anything unless you can cancel it out with the numerator, but 2 doesn't cancel. This 2 and this 2 don't cancel. Don't ever do that. Bad things happen. But if you could cancel, if it was like x minus 2 in the numerator, you could cancel that out. Can't do it right now. So I have x over x plus 1, and I need it to be x plus 1 times x minus 2, because that's my least common denominator. So I just multiply my second fraction by x minus 2 in the denominator. But again, I cannot multiply by, I can't change my fraction at all, so I have to multiply by x minus 2 over x minus 2, because then I'm just multiplying by 1 and it doesn't change anything. So I've got x minus 2 over x minus 2, and now I can simplify and subtract. Okay? Now I've got a common denominator, x minus 2 times x plus 1 and x minus 2 times x plus 1. And so now all I have to do is just subtract the numerators, keep the denominator. Alright, so we need to see if we can simplify this anymore. So we need to try to get the numerator in factored form to see if anything cancels. So I have 2 minus x times x minus 2. So if I multiply in that x times x minus 2, I'm going to get 2 minus the entire thing, don't lose your negative, x distribute, x times x is x squared, and minus 2 times x is 2x. And then all of that is still over x plus 1 times x minus 2. Alright, distribute your negatives, so now I have a 2 minus x squared, and then a minus 2x is a plus 2x over the same denominator, and then rearrange, put it in standard form, all that fun stuff. Alright, now I want to see if my numerator factors. I have a negative x squared plus 2x plus 2. I don't really like that x squared being negative, so I'm going to change that or pull out a negative. And so I'm going to have a negative 1 times positive x squared plus minus 2x, right, because I pulled out a negative, minus 2x minus 2. And let's see if that factors, all over x plus 1 times x minus 2. And then we want to know, does anything multiply to negative 2 that adds to negative 2? The answer to that question? No. So, that is as simple as it's going to get. And x cannot equal negative 1 or positive 2 because that makes the denominator 0. So, we know that's bad. That means I already answered the next question. Okay, let's do example 2. Why don't you try it on your own first, and then pause it, try it, and then you can see how I explain. Okay, so I just rewrote the problem with a little extra space because I know I'm going to have to multiply by things. So I've got x squared over x minus 3 times x plus 2, and 1 over x plus 1 times x plus 2. And so I need to find my common denominator. Both denominators already have an x plus 2, but the difference is that x plus 1 and the x minus 3. So I'm going to have to multiply the first one by x plus 1, so I have all three of them, and then the second one I have to multiply by x minus 3. Now let's combine those and make them one big old fraction each. So now you see I have a common denominator. I have x minus 3 times x plus 2 times x plus 1, and I have x plus 1 times x plus 2 times x minus 3. Okay, they're in different orders, but it doesn't matter because multiplication you can rearrange and put it in different orders. As long as all the factors are the same, you're good to go. So then I can just subtract my numerator. And a hint for you is put the numerators in standard form so you can combine them, but leave the denominators in factored form because you eventually want everything in factored form because it's nicer that way and you can cancel things out easier that way. So this is combined. Now I want to put the numerator in standard form and see if I can factor it all. So I've got x squared times x plus 1, and so that becomes x cubed plus x squared minus x plus 3, right, because I distribute that negative to my negative 3, and then leave that over the same denominator. Alright, when we combine everything, we've got x cubed plus x squared minus x plus 3 all over your denominator, and that numerator does not factor, nor would I expect you to know how to factor it. But if it's something that's factorable, you should factor it and try to cancel out common factors from the numerator and denominator. Anyways, you write your final answer as such, and then make sure you say where x cannot equal -1, -2, and +3, because you cannot have 0 in the denominator. Alright, last example. I say pause it, try it on your own, and then see how I do it. Pause! Okay, I'm going to move on. So, add 3x minus 6 over x squared minus 4x plus 4 plus x over x minus 2. So the problem with this one is that the denominator is not factored. So factor everything first. The numerator of the first fraction, 3x minus 6, you can pull out a 3. So that becomes 3 times x minus 2. Denominator, x squared minus 4x plus 4, that factors to x minus 2 times x minus 2, right? Because -2 times -2 is +4, but -2 plus -2 is -4. Okay, once you have everything factored, then you look and see, is there anything I can cancel first? And I see an x minus 2 in the numerator of my first fraction and an x minus 2 in the denominator. So I can cancel one of those out, x minus 2 and x minus 2. And so I'm left with 3 over x minus 2 plus x over x minus 2. Look at that! I didn't even nearly have to find a common denominator. I made one. That's cool. Okay, so I've got 3 over x minus 2 plus x over x minus 2. So I add my numerators, 3 plus x, and I keep my denominator, x minus 2. And this is my final answer, except x cannot equal 2. Yay! I think that's it. Peace.